Well, let's start with a circle. I know the circumference formula for circles. For right now, let's pretend that I don't. Why, the very easiest length that I know how to calculate is the length of a line segment. So if I can approximate the length of my circumference here with a finite number of line segments, then all I have to do is add up the lengths of the different line segments together. And here in my picture, I have the very same blue circle copied 4 times. In pink, I have approximations with 4 line segments, 6 line segments, 8 line segments. I think that next one is 12 line segments. It's a little bit hard to make out at this scale. And I hope that it makes intuitive sense that as I take more and more different line segments here, that the sum of all the lengths of the pink lines is becoming a better approximation to the circumference of this circle in blue. So, what am I going to do about other curves besides just a circle? And how can I tie this into Riemann sums? Well, I am going to say that my function is f of x, and that the curve that I want is the graph of f of x. So y equals f of x is the most standard way we've been seeing functions. X is the independent variable and y is the dependent variable. Let's go ahead and say that f is a continuous function from a up to b. Well, this should, again, feel familiar. We're going to divide the interval from a to b into n different pieces. Why, the endpoints are going to be x0, x1, x2, and so on up to xn. And let's keep them all the same width apart. We'll call that width delta x. Well, then my picture looks something like this now. In blue, I've graphed the curve y equals f of x. In pink, I've filled in those line segments. Bear in mind, today I am not trying to calculate the area underneath this curve. My goal right now is to calculate the arc length. How long would this blue curve be if I straightened it out and held it up against the x-axis? So to that end, as I'm plotting here, each interval between, say, xi and xi plus 1, I'm just drawing in a line segment in pink. I don't care about the area underneath. All I care about is how long is that line segment. Let's figure that out.